Hello class. In this video, we're going to have the goal of being able to say that we can identify similar figures. Now, before we go into determining whether or not two figures are similar, we have to first ask ourselves, what does it mean for two figures to be similar? Now, two figures that are similar when they have the same design, so a rectangle and a rectangle, a square with a square, but the only difference is their measurements are different based on a scale factor. And what a scale factor is a multiplication rule that determines how much bigger or how much smaller a similar figure will be. Now, there is one important note you want to make, and that's that between two similar figures, there's going to be two different scale factors. One that's big to small and another one that's small to big. So depending on the scale factor, our figure could get bigger or it could get smaller. Now, here's a very basic example of similar figures. And right here, you can tell that we have a rectangle over here, and we have another one over here. We have 4 meters in length and 6 meters in width, and the other one is 8 meters in length, 12 meters in width. And in order to determine whether or not these are similar, I need to make sure that I'm multiplying my length by the same value as my width to get my new figure. Now, this is a very simple example. You can probably easily tell that 4 times 2 will give me 8, and that 6 times 2 will give me 12. And I know for a fact that these are similar because I'm multiplying the widths by 2 and the lengths by 2. I can also show this. Sometimes our figures aren't always so nice. I can also show this by writing a number sentence. 4 times something, which this represents my scale factor, is equal to 8. Now, in order to isolate or to get this variable all by itself, what I'm going to do is divide both sides by 4, because if I want to get rid of my times 4, I do the opposite, which is dividing by 4. I also divide this by 4, and I know 8 over 4 is equal to 2. And I can write a similar number sentence over here, 6, because this is for my width now. 6 times something equals 12. I'm going to isolate this variable, my scale factor, by doing the opposite of multiplying by 6, which is dividing by 6. And once I do that, I can see, again, I still have the same scale factor of times 2. And you can also do this to find the scale factor going down. So for example, I'm going to use this space right here. If I wanted to go from 8 to 4 and identify what the scale factor is going down, what I would do is I would write 8 times something equals 4. Because we're starting at 8, we multiply it by something to give us a value of 4. And just like I did last time, I'm going to isolate my scale factor by dividing by 8 in this example. So here I have 4 over 8, and if I reduce that, because both of these are divisible by 4, I get 1/2. Similarly, over here, if I want to show that the width is also coming down by a factor of 1/2, I can write a number sentence. 12 times something gives me 6. I divide by 12, and I see that 6 over 12 reduces to, again, 1/2. So I know that these are similar again. Now, as long as you can prove that either 4 times 2 equals 8 and 6 times 2 equals 12, or that 8 times a half equals 4 and 12 times a half equals 6, either of these, the red or the blue work, would be enough to prove that these two figures are similar. You don't need to do both of them. As long as you have one, that should be enough. Now, you're going to see here really quickly that these two figures, even though they look similar, they're both rectangles, they both have about the same kind of size, you're going to see very quickly that these actually aren't similar. Now, I'm going to just check scaling up. I'm not going to check scaling down. But if I go from 4 to 12, I'm going to double check my scale factor. I know 4 times a number is going to give me 12. If I isolate my variable, I see here that I get 12 divided by 4, which is obviously 3. Now I'm going to check from here to here. it doesn't look like I quite have the same luck, because 6 times something gives me 16. If I divide by 6, because I'm isolating this variable, I'm getting rid of it. I'm not getting rid of it, but I'm getting rid of everything else. 16 over 6, I can reduce that by 2, I believe, and I end up getting 8 over 3. And I can see right away that these are not the same scale factor. 8/3 and 3 are not the same scale factor, so these are not similar. So whenever you come across a figure that has two different scale factors going the same direction, from small to big in this case, and they don't have the same scale factor, you automatically know that they are not similar. Now, you'll be able to see in a couple examples that your scale factor isn't always a whole number. In fact, our first example, we had 2 1/2. In this example, we had a scale factor of 3 and a scale factor of 8/3. I just want to show you a different example. Here we have a triangle figure, and I want to identify the scale factor from 6 to 8. Now remember, my entire goal for this is to prove that these figures are similar. So I need to make sure that they have the same scale factor. So I'm going to check from my height and my height here. 6 times something is going to give me 8. I divide by 6 on both sides. 8 over 6 reduces to 4/3. Over here, I'm going to have 9 times something, because remember the red arrow determines the change. 9 times something equals 12. I divide by 9 on both sides to get rid of this. 12 over 9, I can divide both 12 and 9 by 3, and again, that gives me 4/3. So these are also similar. And I'm not going to bother finding the scale factor going down because I've already proven they're similar. All I wanted to know is if these are similar or not. Now, you're going to notice in this example, it's going to be kind of difficult to determine whether these are similar or not. One reason is we have a very odd shape. Another reason is our figures aren't quite pointing the same direction. Now, you want to make an important note of this. Figures are not always going to be facing the same direction. You need to look for the corresponding sides. And what corresponding sides are is they're sides in similar figures that match one another. Now, the easiest way to determine this is just by size. So I can see over here that my 4 length over here is the smallest out of this figure, and my 5 length over here is also the smallest. So I know these correspond. Over here I can see that 8 is my next largest figure, and 10 is also my next largest side. So I know these correspond. And lastly, the other measurement that we were given, change color, we'll change it to yellow. We have 12 over here, which is the largest side, and again, our largest side over here, which corresponds with 12, is 15. So I want to determine if these are similar or not. So what I'm going to do is I'm going to check each figure individually. So I know from 4 to 5 over here, 4 times something is going to give me 5. I'm going to isolate my variable, and 5/4 is going to be my scale factor because I know that doesn't reduce. So from my green side to my green side, my scale factor is 5/4. Now I'm going to check my purple side from 8 to 10. 8 times something equals 10. I divide on 8, by 8 on both sides. And 10 over 8 can be reduced by 2, which gives me 5/4. So far, so good. These are also similar. Lastly, I'm going to check from 12 to 15, my yellow sides, and my largest sides. 12 times my scale factor equals 15. I divide by 12 on both sides. And I can see over here that 12 and 15 can be reduced by 3. And again, I get 5/4. So I can tell that these figures are also similar. Now, one thing that you're going to notice in this example is that we have a lot of decimals. And an important note you want to make is that in our previous examples, we've had scale factors that have been fractions, we've had scale factors that have been whole numbers, and mostly fractions and whole numbers. But the important thing to note in here, and our final note on similarity, in fact, is scale factors are not always fractions or whole numbers. Most times in the real world, they're going to be messy decimals, and you're going to have to work with those. But to determine similarity, you still want to make sure that you have the same scale factor. So what we're going to do is we're actually going to use the assistance of a calculator for this next problem. And first thing I'm going to do is I'm going to identify my similar sides. All right, so I know that 1.5 corresponds with 3.39, and I want to go from big to small, just to keep the same, the tradition going from big to small. Now again, this doesn't always have to be big to small. You can go to small to big, as long as your figures, as long as you're consistently going from big to small and small to big. So I know that 1.5 times something gives me 3.39. And just to speed things up here, I can see that 4 times something is going to give me 9.04. I know I have to divide by 1.5 on this side, and that'll still cancel out over here and leave this scale factor available. I'm going to divide this by 1.5. Over here, I'm going to divide this by 4 as well as 9.04 by 4. And we're going to double check to see if we have the same scale factor. So I'm going to have 3.39. So 3.39 divided by 1.5. And I have a scale factor of 2.26. So not a super messy decimal, but definitely something I don't want to necessarily convert into a fraction. So I know that 3.39 over 1.5 is 2.26, thanks to the use of my calculator. And over here, 9.04 divided by 4 is again going to give me 2.26. 9.04 over 4 is still equal to 2.26. So I can tell that these two figures, even though they have some crazy numbers in here, are in fact similar. I hope you reached your goal of being able to identify similar figures. Now, a couple things you do want to keep note of as you're working on your retake sheets. Figures are similar when they have the same shape but differ according to their scale factor. There are some scale factors scaling up and down. And scale factors are not always whole numbers or fractions. Most times they are messy decimals. If you have any questions, always feel free to send me a message on Schoology, and as always, happy studying.